A zero of a function f is such a value x for which f of x is equal 0. So x is a zero of a function if it makes the value of function or y 0. And therefore, if c is a zero of the function, then c comma 0 is an x-intercept for that function. Let's look at two examples. In the first one, we want the zeros of the function f of x equal x squared plus x minus 1. To find the zeros, we need to solve the equation f of x equals 0. We are looking for the values of x that make f of x equal 0. This equation translates to the equation x squared plus x minus 1 equals 0. This is a quadratic equation, so we'll use the quadratic formula to solve it. Let's recall quadratic formula. This is negative b plus or minus square root of b squared minus 4ac over 2a. In our case, a is equal 1, b is equal 1, and c is equal negative 1. So we'll have negative 1 plus or minus square root b squared will be 1 minus 4 times 1 times negative 1 over 2 times 1, which is 2. And doing the arithmetic within the radical, we'll end up with the 5, and therefore the solutions of that equations are negative 1 plus or minus square root of 5 over 2, and therefore the zeros of my polynomial of my functions are negative 1 plus square root of 5 over 2 and negative 1 minus square root of 5 over 2. There are two zeros. Let's look at the example in part B. Function g of x is x squared plus 4. So again, if I want the zeros of this function, I have to find the values of x that makes the g of x equal 0. It means I need to solve the equation g of x equals 0, which means I need to solve the equation x squared plus 4 is equal 0. This is again quadratic equation. We can subtract 4 from both sides to get x squared equals negative 4. Now if you look at this equation, on the left hand side we have the number that is always non-negative. On the right hand side we have a number that is always negative. Those two cannot be equal, and therefore there is no solution for this equation, and consequently there is no real zeros.